Hello friends, welcome back. In the previous video we built the power supply unit for the SCELBI, and here it is. I made a change based on some comments from the previous video. Basically this connector here was modified. It was a male and I changed it to a female, and that was a mistake on my side, so I modified that. And we'll actually use the male version on the SCELBI chassis. In this video, we'll be building the SCELBI chassis, and I have the enclosure here, and it's the same exact box as the one that we used for the power supply unit. It's the Bud Industries 413, I believe, and that's the model number. And basically the idea is to have this SCELBI computer sit pretty much on top of the enclosure like this. We'll mount it to the enclosure. We'll cut a hole out for the backplane, and then on the front of it we'll mount this front panel with the switches, and the switches here, and we will be able to see the LEDs through this opening here in the front of the front panel. And by the way, these PCBs, the PCB sets, are available at Enclosure.com if anybody else wants to build a SCELBI computer, and also the front panel boards, they're also available. Additionally, I have the peripheral boards as well at Enclosure.com if anybody's interested. So I'll put this aside for now, since we won't be needing the front panel just yet. And also the back plane, we'll reference it in a little bit, but I'm going to have to remove all of these PCB boards first before we use it. Let me just tell you a little bit about the other components that I have here. I have quite a bit of these card guides, and the card guides will basically go on the sides of each board. Basically, will mount on the card edges here, and the boards will slide into them just to kind of keep the boards steady and in place. We have a bit of these I/O connectors, and these will basically be used for input and output of the SCELBI computer, and the model number is 78S11, and it has 11 pinouts, I guess. Also, I guess one of the connectors will be the male version that we used in the power supply. I think it's right here, actually. Yeah. So we'll use this one right here for the power. This will contain the power input for the SCELBI computer. And the model number for this is 86CP4. I'll include all the model numbers and part numbers on the GitHub page if anybody wants to reference that. I have a couple of screws here. Also have some wire here. This is a wrapping wire that I'll use for wiring the backplane to the I/O connectors. And also a hole punch, and this is a 732 type Greenlee chassis punch that we'll use to punch the holes for the I/O connectors in the back. Once I punch the holes in the chassis, I won't really need this key punch anymore, so I'll probably relist it on eBay for anybody else that might need it. I'll also reference this manual that I created, and yeah, it's a lot of information in here. I think I mentioned a little bit about it in the introduction of this series, but we can reference it has some information on how to actually wire up the, let me just open it up, how to wire up the chassis and the backplane. And here's some information already, basically input output wiring. We can reference that. And I think there's some other, so front panel control switch wiring, we'll reference that. And I think it also has some diagrams on how to orient different, so right here. So we have a diagram on how to orient the backplane, and also how to configure the I/O and the power connectors on the back. And it also tells you how to orient the power connector also. So we'll reference that, also the switches. And here's another layout. This is from the top view. Yeah, so this will be useful for our case when we assemble the chassis, so I'm going to reference that. To start off, I think it will be a good idea to assemble the edge connectors on the backplane, which I sort of started already. I just soldered in a couple of the pins here to keep them in place. I think I might go ahead and solder in the remaining pins here. And by the way, you don't need to solder all the pins, just the ones that have connections to them. You also check on the front here if there's connections. And the reason why we want to install them now is because we want to use it to basically place it on this chassis here to make some markings and to cut out a hole. And we want to orient it or align it with right in the center this way, or I guess left to right. And front to back, we can basically orient it with maybe a 1/2 inch clearance from the edge of the PCB to the edge of the chassis. And then we can make markings where to cut out the holes. And we want to cut the holes along the edges of the edge connectors right here, and also on the front and back, so that we have so we have some chassis left over for these screws to mount the backplane to the chassis. So I actually went ahead and made those markings, and also made markings where the screw holes are supposed to be, so I'll drill that out. So we're going to cut out this square rectangle right here, and this rectangle here, and also drill out the holes for the outside perimeter of the backplane. We'll actually drill out the holes for the edge connectors later. Also, on the back here, we want to cut out holes for the I/O connectors and the power connector. And to do that, we can use a little template. And I got this template right here. I think Mike Willigel created this one. I just modified it. Basically, I imported it into Photoshop and adjusted the sizing for this chassis here. And I'm going to share this Photoshop file with you, and also the JPEG file. But if you open the Photoshop file, you can just print it at the specified size for the Photoshop file, which is 12 inches by 3 inches. And you can print it on a 8.5 by 11 piece of paper, and it'll give you the right dimensions. And we want to orient the template with this empty spot where we won't have a connector, so that it's actually on the top left of the chassis if we're looking from the front. So what I'm going to do now is I will sort of align it in the middle here, add some tape around it, and then I will drill out these holes where the axes are using a 1/2 inch drill bit, and then we'll insert the key punch and make the holes for the I/O ports and the power connector. So I'm going to go ahead and do that. I will cut out the holes right here on the top for the PCB, the backplane, and also cut out, I guess, punch out the holes for the connectors in the back. Alright, so I got the enclosure cut out here, and you may have noticed that I actually cut out the center piece here that I was thinking of keeping, and the reason why is because the backplane wasn't fitting because of these edge connectors being in the way. We could have a single thin line here, but that's just too small. I think if we have support issues in the future, basically if it bends too much, I might add another support here. But the way it'll fit in here is something like this. And there you go. And then we'll mount the backplane using these mounting holes here. And you probably noticed that it's not as shiny anymore. That's because I kind of did the brushed aluminum look to it, and that's because I kind of scratched it up while I was cutting the hole out using a Dremel tool. So I thought I might as well just brush it up a little bit. Also in the back, I drilled out 1/2 inch holes for the I/O ports and the power connector. And I actually went ahead and punched the power connector hole here. And the tab kind of broke off here, but I'm going to go ahead and punch out all the other holes. And let me just show you how it's done, just so we do it the right way the first time. So the hole punch has 4 pieces. It has this little piece here with the axle, I guess, in the middle that will slide through the hole, and also this piece here, and has a little tab in here, and that's what actually creates a tab. And it will click in on the tab here together like this. And the reason why it's separate is because when you cut it out, the piece of metal that's cut out will be stuck in there, and the way to take it out is just to separate this and remove it. And we'll go ahead and insert it from the outside, and the reason why we want to do it from the outside is because we can't really fit it through there when doing it from the inside. It kind of, this big piece doesn't fit, kind of hits the edge here. Doing it from the outside will leave a little mark here, unless you add some tape or something, which I plan to do here, but it's not too big of a deal. Yeah, and also we want to face the tab here the same direction. So in my case, I'm going to face it all downwards. So let me go ahead and try to punch out a hole. This side right here also has a tab, and we just need to align it with the tab on the other piece. And the last piece is the nut here, and we'll align it with the tab facing down of the enclosure, and then hand tighten the nut. And once it's tight enough, we'll tighten the remaining part of it with a wrench or something like that. I'm using a size 19 wrench. Okay, well, it punched it through, but unfortunately it broke the tab again, so I just need to be a little bit more careful when I punch these holes. I think I have to kind of keep it in place so it doesn't fall off on its own. But yeah, there we have another hole. So we have holes for the power connector and one of the I/O ports, and we have to punch out the remaining I/O ports, so let me go ahead and do that. Alright, I just got all the holes punched out for the I/O ports and the power port. Unfortunately, the tabs broke off for pretty much all of them, and I think the reason why is because it started twisting when I was tightening the nut, and it just kind of twists the tab off. And yeah, I couldn't figure out a way to actually keep the tab in place. If anybody knows how to actually do that, please let me know in the comments. But I think even without the tab, we can make it work. So yeah, I think the enclosure is pretty much ready to accept all the components that we're going to add to it. Before we insert the backplane, I actually want to insert the connectors here for the I/O ports and the power connector. And we can reference the SCELBI official manual just to know where all the connectors go. Actually, by the way, I forgot to drill out the holes for the switches still, which I'm going to do a little bit later. But as we can see here on the manual, we have I guess the bottom section of the enclosure are all the output ports, and the top part is the input ports. So we have 6 input ports and 8 output ports, and the power connector. And it kind of shows us how to orient the connectors. Each connector has a little tab, and that tab in this case is actually pointing down. So let's take a look at one of the connectors here. As we can see here, this connector has a little tab, a slot here, and the mating connector also has a tab that will slide into this opening here, that slot. And so we want to orient it so that the slot is facing to the bottom of the enclosure, as it shows here. So we'll orient it something like this. And the reason why is because the pins are numbered a certain way, and the pin 1 should be on the bottom, basically. Pin 1 starts right beside the tab here. So we'll insert all of these I/O ports in the same direction. And then for the power connector, we want to orient it so that the bigger pins are facing to the top of the enclosure. So in my case, I have the bigger pins here. I'll just insert it like this. Okay, so let me go ahead and insert all of these I/O ports and also the power connector, and then we'll be back. And we're back. I got the I/O ports inserted and the power connector inserted. And on this side, we basically have these O-rings that are keeping it, I guess they're called O-rings, that are keeping the connectors in place and from moving around. And it works pretty well. I think there's one of the connectors that just has a bad ring and it just kind of keeps on moving around. I forget which one it is, but it's this one right here. But I'll probably insert another one in there just to kind of improve that. This process of inserting the rings can be a little bit time consuming because it's just a little bit frustrating to kind of try to get them in place sometimes. But once you get a hang of it, it goes pretty quickly. Okay, so we got the connectors installed. We will wire them up a little bit later. I guess to wire them up, we need to insert the backplane in here. But before we do that, I want to actually drill out the holes for the switches. If we place this front panel over the top right here, we can kind of tell where to drill the holes. But as you can see here, I'm kind of aligning the bottom of the front panel with the bottom of the enclosure. But the thing is, if I have the backplane inserted in here, and I have the front panel board inserted into the backplane, it will not align exactly with the open. So the LEDs won't align exactly with the opening with the front panel. And the reason why is because I sort of modified this front panel in such a way that the backplane can be lowered a little bit to lower the front panel board to align with the opening. Like if you want to insert some sort of spacers or anything like that, or you can just raise the front panel slightly to make it align. So there's two options: either to lower the backplane a little bit with some spacers, or raise the front panel. And in my case, what I'm going to do is I'm going to leave the backplane as is, just directly touching the metal part here. And the reason why I was thinking of potentially having spacers was because I thought that some of the traces here would be touching the metal part, but it looks like we don't have any traces there, so we're good there. And I just want it to be just flush with the directly touching the enclosure. And instead, what I'm going to do is raise the front panel here slightly higher, and basically to mark the openings of the holes. And I think it might be about an 1/8 of an inch. That's how much we have to lift it. So if we look on the bottom here, and right now it's aligned with the bottom of the enclosure, I'll just raise it about 1/8 of an inch higher, and make my markings here for the holes and drill them out. So I'm going to go ahead and measure it. I'm going to clamp it down just so it doesn't move around, make the markings, and drill out the holes. And by the way, on the sides here, just make it centered as much as possible. To me, it looks about a quarter of an inch on each side. Okay, let me go ahead and make the markings and drill out the holes. All right, I just drilled out the holes. I think the holes need to be, basically for the push buttons, the holes need to be 1/4 inch in diameter, and the toggle switches should be 9/32 in diameter. And I think those are pretty close. Now we can actually go ahead and install the backplane. And before we install the backplane, I would recommend soldering in all of the edge connectors here, and I actually went ahead and did that not too long ago, and it took me maybe, I'd say maybe 1.5 hours or 2 hours to solder all the pins on the connectors. But I'd recommend taking your time because it is a time-consuming task. We need to make sure that we orient the backplane correctly. If you look on the back side of the backplane, we have XA, basically some markings here. So XA02, XA04, 06, 08. So basically we want to start with the lower number towards the front. So XA02 would be facing the front. And it's really the thinner part of the mounting hole. So we have maybe a ½ inch here and a ¼ inch here or something like that. So we want to have the thinner side facing forward. Because the backplane is designed to accept all the PCBs in a certain order, and we want to make sure we respect that order. Alright, so I just inserted it in, and now I can mount them with some screws. And I'll be using these, I think these are ¼ inch, with a pan head. I guess it's called a pan head, or cheese head, or something like that. Basically, it's a flat side on top. I'm going to go ahead and mount them with these bolts here. So we have it mounted, and I think it looks pretty good. It fit the screws fit pretty well, so I'm happy with that. Yeah, it looks great. So let me try to insert a PCB into them, well, into the backplane, just to kind of see how well it's supported. So the front panel one fits pretty well. What if we insert, let's say, in the middle here? Yeah, it's not too bad. It does bend a little bit in the middle here, but it's nothing serious. So we probably don't need any support there. I now want to mount the switches here in the front. And when we mount the switches, we will also need to mount the front panel because they come together. They're attached together. And the reason why I wanted to mount the switches is because when we start wiring up the backplane to the I/O ports here, I just want to make sure that we have everything that we need to mount to the backplane, including the switches. So let me get the switches and start mounting them. Alright, so I got these push button switches. Got a DG key. We need 3 of them. I got 5 just to have some extra. Before we mount the switches, I will actually place the front panel in its position and then mount the switches. The reason why is because we're mounting the enclosure with the front panel together. So we'll start with the push button switches, actually just one of them for now. And there's only room for one nut to be installed. We can't really use this expansion washer, unfortunately. And then one of the toggle switches. And it doesn't really matter which way we install it. It matters how we actually mount them later. But let's go ahead and insert this side with the groove facing up, just for consistency. Alright, I got them all installed here. I'm just going to reinsert these push button caps over top of them. Perfect. It just clicks in there. And the last one. Wonderful. Yeah, so I think that looks actually pretty good. We have 8 toggle switches and 3 push down switches. And now I just got to tighten them, and then I think we'll be ready to solder all the wires for the switches and also for the I/O ports. Also, I just want to mention that if these front panels are no longer available or out of stock at Enclosure.com, you can still make one yourself by using the CAD file provided in the GitHub page that I will link to in the description. And let me just show you how to actually upload the CAD file to PCBWay so that they can actually fabricate the front panel for you. On PCBWay.com, we can click on CNC 3D printing, and then select sheet metal from the menu. Click Get Started, and then it's gonna select sheet metal for us here on the menu item. But then we have to upload the file, and we can drag and drop the file in here, or we can click on it and select the file from the file menu. And there are 4 different options and 2 variants, one without text and one with text. And I haven't tried the one with text yet because basically it's to print the text on the front panel, but I haven't tried that, so we'll just go without text. And we'll just select the SCELBI 8B without text IGES file. And it'll upload the file for us. And right now it's showing us the price is $35.72. We'll select aluminum as the material, and we'll leave the defaults as is. The thickness should be subject to 3D file, which is right now 2.5 millimeters. And then we can click on surface finish to give us that blue color. We can click on anodized, and then select anodized from this list again. And select the blue color, click submit, and then click OK here. The rest of the options can be left as is. There is one thing though you could change, and that is the silk screen selection here, and that's to actually be able to upload a sort of silk screen or labels to be printed on the front panel, which I haven't tried yet. Scroll down, and then for product description, we can select DIY Entertainment from the list here. And select, for example, demonstration model. And right now the price is $42.59 approximately. And now we can click on Submit Request, and it'll send a request to PCBWay, and they'll review it. And it'll take probably a day or maybe a few hours to review it. And they'll give you the final price, but it'll probably be around $45 or so plus shipping. And that's pretty much it. And that's how you can actually make your own front panel for the SCELBI computer. So we got the front panel installed along with the switches, toggle switches, and push button switches. And now what I want to do is basically see if we want to see where the LEDs actually show up through the front panel. So let me go ahead and insert the front panel PCB board into its position, and now we can verify the position. And I think it looks pretty good. It's pretty straight. So yeah, I'm pretty happy with the placement of the front panel. Okay, I'm going to remove this front panel board from the backplane. And then I'm going to install these card edge guides. I think that's what they're called. And they'll just go in here like that, basically all along on this side and also on this side. And we can mount them with regular bolts here too. I think these are 632. No, these are 440. Yeah, so I'll use those to mount these on each side of the backplane. I just installed one set of these card guides, and let me see how it would actually work with the board being inserted. I think it works pretty well. Let me do this again. It's a tight fit, but maybe that's a good thing, just to kind of keep the boards solid and in place. So I think that looks pretty good. All right, I'm going to go ahead and install the remaining ones here. The next step will be to wire up the backplane to the I/O connectors and also the switches here. And we'll do that here in a little bit. I just wanted to mention something before we do that, and it's about this part right here. If you look here, you can see that these nuts here are actually touching this passing trace, and these nuts are connected to the enclosure because I'm pretty sure they're touching it because there's a hole there for each screw. So we want to make sure that we don't connect anything to the enclosure, like for example ground, because that trace, it'll basically create a short with that trace, and we don't want to do that. Okay, let's go ahead and start wiring up the switches, and then we'll move on to the I/O connectors here and the power connector as well. I added some tape here on the front with the labels for each switch, just so I can kind of know which one, which switch means what for testing and for wiring. We'll actually add labels to the front panel a little bit later. Alright, I'm going to turn it upside down, and we're going to start wiring the backplane here. And the way, I guess one of the ways you can actually place this is basically on a table like this, with the front panel here overhanging the table, something like this in my case. And we can reach pretty much everything in here. Another way is to kind of do it like this. And actually I like this better because the everything's facing towards you, so you can kind of work a little bit easier. And I think I'm actually going to have it like this in my case. So we're going to start with wiring the switches on the front panel. And if we look at the manual here, on page 18 of the construction manual, I believe that's what it's called. Let me just kind of double check here. Yeah, so the assembly instructions manual, page, I don't think it's page 18, but it has an 18 on it. Oh, okay, so it starts, let's see, where does this start? Installation instructions for the chassis portion. Okay, so the chassis portion, page 18, the heading is for wiring the front panel control switches. And if we look on page, I think we already looked at one of the pages for where we actually can see, so page, I don't know what page this is, but basically this page right here. And this is looking from the bottom, so the switches are reversed, like the push button switches are on the right side here. And I just want to mention something here. So it kind of shows you how the connectors here are oriented. So it starts with XA1. Yeah, so it starts with XA1 and goes all the way to XA9 here. So from the front to back. The right side will be the A connectors, and the left side will be the B connectors. And each connector has pins numbered. So if we look from the right, so it's from right to left. So from the right we start with 1 and we go all the way to, I think, 22. And the pins facing away from you, if we're looking from the front, it starts with A and goes to, I forget what it goes to, but basically A, B, C, D, E, F, and it skips the letters G, I, O, and Q. Just because they're just so close to some other letters and numbers, they're just omitted. I think it actually goes to Z, if I'm not mistaken. So that's the way we have it here. Actually, I just noticed that I have the chassis facing away from me, the front panel facing away from me, so we kind of have to reverse this for the wiring, unfortunately. But if we look on the back plane, not all of the pins are actually numbered. Only the ones that we will actually use for soldering, for example, the switches or the output ports here, have numbers and letters. So just it's going to make it a little bit easier to work with. Also, these switches have numbers too. So these push button switches start with S1 and it goes to all the way to S11. And I think that's enough for wiring the switches. So let me just go back here on the list of switches that need to be wired and take a look at that. So the way it's organized, and it's actually very similar to how the backplane is actually organized, all the wiring on the backplane. Basically everything within each section, basically between the dashed lines here, means that they connect together. So for example, this line here, XA2 and so on, is connected with the same plane or same line as the S1 TP2. And the way we look at it is like this. So for example, XA2 is going to be this line of connectors here, because we can see the XA2 row. AH, so the A is going to be the A column. So again, we have the A column here, as we can see the A designations here on this side. The B column will be here. So AH, so XA2 will be this row, A column, and the H is right there. So we can see the H pin. So the H pin will wire to switch 1 TP2. So switch 1 will be one of these, actually the first push button switch. So we will wire that pin AH to the TP2 pin of switch 1. And honestly, these you can't really see it, but these push button switches, they only have 2 leads, so it doesn't really matter which pin we use. And that'll be it. Basically, that part will be done. We can just check it off once we make route a wire to those 2 pins, and then we can go to the next one and so on. On the next page here, we have, as you can see here, let me actually just go back here. Yeah, so this part right here, all of these wires are connected together. As you can see, they're all between these 2 dash lines. So all the switches, S1 through S11, and also XA01, A03, all the switches, basically, we want to connect TP1 of all the switches to common or ground. And we can just basically run, so TP1 will be the center pin of the toggle switches, and TP1 of the other switches is just the other pin that hasn't been wired of the push button switches. So we just need to connect one single wire between all of these switches and then connect it to common ground, which is this large trace right here. It actually has a C beside it for common. And that is pretty much it for wiring the switches. There are some jumper wires that basically don't go to any of the switches. They just kind of, I think they all go to the common wire here. So I forget which one it is. Maybe, yeah, so right here. So AR and AC of XA2 are connected together. Actually, and I think they connect to, yeah, so AC is actually ground, so AR connects to ground. So just to keep that in mind. I'm going to go ahead and wire up my switches and then show it to you, just to so you have an example of which wire goes where. Alright, so I just added all the wires and I marked them off the list. I think that's a good idea. Just while you go through all the wires, just mark it off just so you don't miss anything. And here's the end result. So there are jumper wires right here. There's one right here. There's one between X and Z here. There's one between the Y here and the F here on the B side. And there's one from I think is J to C, and also R to C. And I think the remaining jumper wires, the remaining wires are all connected to the switches. So the common wire on all these switches, I just got one single wire. It's just bare wire here, connected to the center pin of these toggle switches and one of the pins of the push button switches. And it connects them all together and then runs to the third pin here, the C, the common trace. And all the remaining wires are routed to the correct pins based on the list that I just showed. The toggle switches, we should wire up the top pin. whenever the computer is facing the right way, it's going to be the top pin. Right now it's actually on the bottom, but basically that means that when the switch is in down position, it'll be grounded to the common wire. Basically it'll be ground, and that's how we actually specify a 0 or a low in the computer. And I guess the top one will just be not connected to anything, and that's pretty much it. I use some zip ties to kind of organize it a little bit, but the way you do it is up to you. The wire I used was this wire wrapping wire. It's pretty thin, but it works well. We're going to use the same wire for routing the I/O ports here as well. Okay, let's go ahead and move on to the I/O ports and also the power port as well. As with the switch wiring, we're going to use this sheet right here because it kind of has an outline of where each wire goes. And also it has the output port designations. So for example, SK1 through SK6, then SK7 through SK14, those are output, and the top ones are inputs, but they're actually upside down here. So there's 6 inputs and 8 outputs. And again, if we look at the manual, like for example here we have on page 20 the inter I/O connector wiring. Actually, you can start from the top here, basically the input output wiring, but it starts with the inter I/O connector wiring, and what that means is basically we're gonna wire each port to each other. Some of the wires are connected together. So for example, here we're connecting all of pin 1s of each port together, and that's actually going to be the ground pin. And it goes all the way to here, and then we have all of pin 1s are connected, pin 2s, pin 3s of all of these ports right here. So we'll do all of those, and it goes all the way to page 23. And then it has the output data bus wiring. So basically now that we have connected all the inter I/O ports together, we can actually start connecting every pin to the backplane pins. So here we have output ports 10 and 11 being used for connecting it to the backplane. So basically pins 1 through 8 are connected to the backplane at these locations here. And then we have the output strobe wiring, and basically we're connecting the pin 9 of each output port to a backplane designation. Basically the strobe is triggered whenever an output some data is being outputted on that specific output port, and it'll be basically wired in such a way that we can actually strobe it on all of these 8 pins, 8 ports independently. And then we have input port wiring. Again, we're connecting all the pins to the backplane here. And there's a couple of them here. They're all separate. And that is pretty much it. And that finalizes all of the I/O port wiring. And we're also going to connect the power connections to the power output. So like, for example, on page 16, these are actually... these here are actually showing us how each pin on the backplane is connected together, basically how each row is connected together, which is already accomplished by the backplane, and that was already something that I already did. I connected them all together. And now what we just have to do now is connect basically one of these pins to the right output port here. So I think it's PL1 right here. So the power connector port is PL1. We just have to connect it to the right pin. So pin 1, for example, here. And we just need to connect the positive 5 volts, which is AA and A1 on the back plane here, and which is on this side. So AA and A1, these 2 pins. As you can see, they're all connected here together. All we have to do now is basically connect them together, connect A1 and AA together, and also connect that to PL1 pin 1 here. And for ground, we do the same thing. These are all connected together, but actually on the backplane here, we went ahead and connected the C and the 3 together, so that's all good there. We don't have to do it ourselves. But then we connected to PL1 pins 2 and 3. And also we connected to SK6 pin 11. So remember we talked about connecting all of these I/O ports pin 11 together, which was supposed to be ground. This is where we actually connected to ground directly, basically connect all of them to ground. And lastly, there's the minus 9 volt rail, and we connected to PL1 pin 4. And that is pretty much it. I'm actually going to start with all of these interconnections, and then I'll move on to connecting the ports to the backplane, and then finally I'll finish by connecting the power connections to the power output port. And by the way, you don't necessarily need to connect any of these I/O ports to the backplane. You can just go ahead and finish the computer boards, put them in, and the computer will function without these I/O ports. You will need the power connector. But also, if you are not expecting to have many I/O ports, and this is a time-consuming task, so if you're not planning on having many I/O devices, then you might actually opt to just wiring 1 or 2 of these I/O ports. It's going to be a little bit less work. But in my case, I'm actually going to go ahead and wire all of them up. Okay, let me go ahead and wire it up, and I'll be back. All right, I just got the ground pins connected, pin 11. So basically, all of these I/O ports, pin 11 is connected together. Port 12 and 6 are connected together. So basically, the output port 12 is connected to input port 6, and that's how it connects both rows together. So I'm going to continue connecting all the other wires that interconnect the I/O ports, and then we'll move on to actually running wires from the ports to the PCB. We got all the wires soldered in and routed, and this is a fairly long process, but I actually enjoyed it, so it was pretty fun. I used this blue wire that I showed you earlier. It's a wire wrapping wire, and it works very nicely for this sort of setup where we have like a lot of wires running in a group. And if you do have a wire wrapping tool, the one that you twist, it works. It'll help whenever you solder in the connections on the PCB, because you can just kind of wrap it around each pin of the edge connector. So I got all the input and output ports connected to the PCB. The output ports here are connected all together. And then we route all 8 pins to the PCB somewhere here. And also there is a individual wire for each output port, and which is actually for the strobe to tell the output port that there's new data on it. So all that is routed to another location of the PCB. All the other ports here, the input ports, they're all individually wired up to this, I think, XA04 row. So we have 6 input ports. And also wired up the power connections here. So the black wire, the ground, connects to the large trace here, the C, the common trace. And both the number side and the letter side is already connected together. So basically, what is it called? A3 and AC. For example, A3 and C are connected together, so we don't have to do that. But for the positive 5 volts and the negative 9 volts, whenever we wire it together, make sure to solder it to both the 1 and the A side for the positive 5 volts, and the 5 and the E side for the -9 volts. Basically soldered the 2 pins together. On the connector side here, both of these, I guess it's upside down here, but basically whenever it's right side up, the 2 bottom connectors will be the ground. So I actually wired up both of them to ground. And also ran a wire from ground to pin 11 on all of these I/O ports. And then I used some zip ties to make it a little neater, and added this little holder here. I forget what it's called, but I glued it to the PCB and added a zip tie to hold the wires in place so they don't sag whenever we flip the enclosure right side up. It might be a good idea to actually use a sort of some sort of continuity meter to make sure that all the connections are correct and going to the right place. So we got the underneath wired up with all the connections here for the I/O ports and the power connector. And I actually went ahead and added some labels to the front. And these are just some, I guess, temporary labels, because I want to figure out a way to actually print the labels directly on the front panel. But for now, I'm using these sort of sticky labels that I got off some website. I think it's called like Sticky Life or something like that. I can include the PDF that I use, or the image file that I use for these labels here if you want to use them. They're going to be in the GitHub repository. But I think it looks pretty good even with these temporary labels. We know where all the what each LED here will mean, and also which switch does what. So pretty happy with that. I also went ahead and created a power cable that we will use to connect this SCELBI computer to the power supply that we made in the previous video. And these are the connectors that I already introduced earlier. So this side is the same type of connector that we used on the power supply side. And this is the one that we use right here on the back of the SCELBI computer. And these are just some covers that I got on eBay for them, and they just slide into the connectors. And the cable here, I can also include a link to it in the GitHub repository. But this cable right here is basically, I forget what gauge it is, maybe like 18 gauge probably, or 16 gauge. But basically it has 12 conductors inside of it. And we will use the same cable for creating basically the connectors for the I/O ports, since we need 11 conductors there, and this one has 12. And what I actually ended up doing is I took three wires and connected each pin here with 3 wires. So 5 volts has three wires. The 9 volts or -9 volts has 3 wires, and the ground actually has 6 wires, so 3 on each pin. And I did it on both sides, soldered them in, and made this little connector. So let's go ahead and try to plug it in. And this is actually a keyed connector, so that means that it will only go one way. And if you try to hook it up a different way or the wrong way, it shouldn't go in. But don't force it too much, because you could probably still push it in if you try hard enough. All right, so we hooked up the SCELBI side. And on the power supply side, we'll do the same thing. So we'll just slide that in. And there we have it. And I'm going to go ahead and turn it on. Okay, so now we're getting actually power from the power supply, and it's going to the SCELBI computer. And actually already tested it on the SCELBI computer to make sure that the voltages were correct. We just want to make sure that we're actually getting the right voltages for the positive 5 volt line right here, and also the minus 9 volt line on pin 5 of the backplane. Just need to verify that. And that's pretty much it. I think we're finished with the enclosure for now. I'm going to actually add a little cover here a little later. Well, I hope you enjoyed watching this video. Don't forget to like and also subscribe if you haven't already. We'll be posting additional videos soon where we're going to be building the PCBs that will actually slide into this computer. I think there are 7 PCBs or maybe 6 that are required for the SCELBI 8B. So we'll make a video for each one. We'll basically assemble each PCB in each video and test it out and things like that. I know that the CPU board will need some tuning of the clock, so we'll also do that in a CPU video. But yeah, don't forget to subscribe if you haven't already, and I'll see you in the next video.